Okay, we want to look at how to test a graph to see if it might be a power function or an exponential function. So how do we test for power function and exponential function behavior? Well, we know that a power function has a constant y factor, meaning that if x values double, then the y factor is going to be the same. Okay? And the y factor is the ratio of y values. We know that. And then if it's an exponential function, then it's got to have constant doubling displacement. So we look for the displacements over which the values of the graph double, the y values that is, double, and see if that happens over the same x factor. Now I've just drawn a curve here, and I kind of intentionally tried to draw it so it's neither a power function nor an exponential function. Let's see if I succeeded. Okay, so do we have a constant y factor? In order to test for the y factor, we create a sequence of doubling x values. Okay, let's see if we double that, we get out to here. Okay, and then we see if y changes by the same factor between any two given x values. Now the y values correspond to the lengths of these dotted lines. And we can see rather clearly that between here and here, the y value drops by more than half. Okay, this is less than half of this. This has less than half the length of this, maybe about 4/10 the length. So it looks like we have y factor. What do I want to label this now? Y factor 0.4 between these doubling x values. Between here and here, the y factor is clearly more than half. Okay, very clearly less than half as we go from here to here. Very clearly more than half as we go from here to here, because this is considerably more than half of this. It looks like it's maybe 2/3. Okay? So let's say the y factor here approximately 2/3. And we can say that we clearly not the same. So this is not a power function. Now, is it an exponential function? Well, we have to look at doubling displacements, and one way to look at that is simply we take a value at some point on the graph here, and we have a y value. Okay, now we want to find a point where the y value doubles. Now, the y value, of course, is decreasing as we go out here, so to find a doubling displacement, we'll have to go from a point out here to a point here. So let's see, this y value is halved about here. So let's see, between this point and this point, it appears that the y value more or less doubles, assuming I've made a good estimate. So that a doubling displacement, and I think I said doubles from here to here. From here to here, the y value doubles. The doubling displacement is therefore this much in this direction. Now let's cut that y value in half again, so that we have another doubling displacement from here to here. Now, doubling displacement, of course, is the change in the x value, and if we sketch an arrow corresponding to the doubling displacement from here to here, it looks like it's about the same. So it looks like maybe I didn't succeed. It looks like maybe I did have exponential behavior. So maybe I messed up. Or maybe we could find another pair of values, maybe here and here, where we have a different doubling displacement, but it kind of looks like this one is conceivably exponential. Okay, so kind of looks like it. Kind of looks like it's so. Let's make it a little clearer.